Well, not.
Good morning, good evening, good day, greetings, and salutations. And might I throw in, as always, a welcome to the Safe Room featuring Security SideQuest. My name is Tristan Waddy, and I'm joined today by the mysterious, the Maven, the Maverick, Russ. I forgot there was a fourth M, but I might add it in at one point, right?
Malevolent.
Malevolent? Yeah, we'll go with that, right? And just by the end of the year, it's just going to be 40 M's, right? we'll just keep that on. But
right.
Yeah, Russ, say hi to the people.
Hey everyone, I'm Russ. I'm from the customer incident response team. I hope I never have to deal with you.
Yeah, and me, I hopefully get to interact with you and talk with you because I am from the AWS professional services team where we help customers accelerate their journey to the cloud in a secure manner so that you eventually won't get to Russ. So I also say hi. Nice. Thank you for joining in. And feel free to put in the chat where you're dialing in from, where you're tuning in, where you're listening from, whether it be radio, Walkman, or something in between that, right? Depending, because yeah. So
Walkman would be impressive if you got a recording of this already. That's good. I like that.
It's in the future, right? Because it kind of goes with the topic, right? It's multiple states at once. But also, feel free to also answer the other question that we have. And it's a special question that I will throw out to Russ. And that is, what is your favorite sandwich? Go.
I'm going to have to go with a Cuban.
Oh, nice.
I am, big fan.
So this is an interesting thing. So as we're talking about different states, what do we consider a sandwich?
Don't do this to me. Don't do it. No, we're not doing this game.
What is a sandwich? Is a hot dog a sandwich?
Actually, you know what? I'd actually love to. I can't wait to hear our guests' answer for this. Can we just skip right to the guests and get our
just get it? Just the food topic. It was just forget about
let's go. Sandwiches. What do you consider a sandwich? That's actually a better question.
Yeah. What do you consider? What state? Or speaking of what state, Pete from GA. Thanks. And we have somebody from Brazil. Thank you for joining in. And Waffle Ice Cream. See, they went to the seminar about sandwiches.
Oh, ice cream sandwich. You're right. I totally forgot about that.
Exactly. See, and peanut butter and honey on toasted bread. That sounds pretty good.
That is a good
sounds like a sequel that we should have. And checking in from Washington, D.C. Oh, sandwich is a sandwich.
Thank you.
Unless
sandwich is a sandwich.
Yeah. But I would say for me, my favorite sandwich, I would consider a hamburger. And what kind of hamburger? Peanut butter and hamburger. So, and I just leave it there, right? And just move on without any explanations or anything like that because we're having fun today. This is a Safe Room feature Security SideQuest, right? So, you like the dramatic pause that we
Are we having fun?
Yeah, I think we're having fun.
Anymore.
Yeah, a burger qualifier, right? So, Russ, what are we here to talk about today?
So, as you know, or maybe you weren't here, but that's okay. Last week, we went over the last of keys, understanding quantum security impacts. Today, we're going to go a little bit further. Today's episode is the right man in the wrong place. We're going to be talking about implementing quantum safe security procedures. So we're going to get a little bit into that. Thankfully, we have some amazing guests who will do a much better job of explaining that than I probably will. So,
yeah, and that's the funny thing is because the title is The Right Man in the Wrong Place, like me in a sandwich shop asking for a hamburger with peanut butter. But I'm going to leave it. I said it twice, right? I'm going to leave it alone. And I think to start this off, maybe we'll have a little bit of a poll. Not of the sandwich, sadly, but we'll get into something else. And that, I would say, is quantum computers are coming. Your first move, what is it? And feel free, 1, 2, 3, 4 in the chat. Select your destiny. What is your destiny, Russ?
I'm gonna have to go with trained security teams. We're gonna get into why in a little bit, so spoilers or whatever. But I think training security teams to understand what is quantum computing and how relevant is it to your environment. Is that something that you're going to be concerned about? If you're just a financial organization, probably not, right? If you're a research lab, maybe.
Yeah.
So again, I think for me it depends on your threat model, and so I think training security teams for realistic expectations would be my answer.
See, and the funny thing is, we're having a split across. So that means I have to go with one. I fortify the Lambda network, right? Because we have so many Lambdas out there. We have to have somebody fortify it because nobody seems to be looking at it. So can anybody tie break? Put in the numbers in the chat. It's just interesting to see where everybody's kind of coming from with that. So, Russ, you said train a security team. Well, the way we can train the security team is by jumping into the kind of the overview of today, because what are we going to talk about? Quantum. And how are we going to talk about it? Well, it's going to be interesting because we're going to talk about some key management strategies. How does that apply? Well, stay tuned and you'll find out. Enterprise scale quantum safe architectures. What are they? What are the use cases we have? Do we need use cases? Because it's theory, right? Isn't that kind of the talking point with that? Is it just a theory? A quantum theory, something like that? If you get that reference, 10 points to you. But I think we are the people that have to get trained today, Russ. I think we need to bring in some help. We need to bring in some people with wisdom, some people who are the stage. Yeah, with the auras, right? That dripping. Yes, they're just dripping off of auras of quantum knowledge that they're going to share with us, impart on us. So today, our two guests is we have Daniel and Desiree. Welcome. Thank you.
Welcome, guys. Yeah. We need the cheers bot.
Yeah. Yeah. I'll just have Russ. We'll just go every time. Yeah. But thank you for joining. Introductions. We'll start with you, Desiree. Where are you from in the Amazon world?
Yes. Thanks. Ladies first, I guess. So sorry for that, Daniel. So I'm a security solutions architect. So I'm a bit on the more salesy side. So I'm not an engineer, but I'm more customer facing, also looking into how I can mitigate problems on security and compliance side, and also have like fun topics with quantum security. So yeah.
Nice. Thank you. Daniel.
My name's Dan Deter. I'm a senior security specialist with our public sector organization, worldwide public sector. So I work with government as well as our ADCs, our secret and our top secret regions. I am an enterprise account engineer. And so if you know AWS, you might ask, what's the difference between a solutions architect and an enterprise account engineer? We don't know either. We're all just nerds. And we often work very closely together, doing as partners on driving positive customer outcomes.
Yeah, and that's the funny thing is a thin line between nerddom and quantum, right? That's the saying. I think I heard it. If not, I'm going to trademark it and kind of write a book on it, right? That's what I should do. A thin line between nerddom and quantum. And it would be a fairy tale.
Dr. Tristan Waddy story.
Yeah, exactly.
Well, Tristan, today we are still in the generative AI phase, so you have to make everything Gen AI. Quantum will come a few years later.
Yeah, or the book can be, put in a time.
You got to get ahead of things.
Yeah,
you got to get ahead of things.
Do you recall when they used to put the little time capsules in the floor and they're like, "Hey, kids, put in a toy or something in 30 years."
I got a story about that. You don't want to hear it though.
We'll write it down and put it in the same capsule.
My hand is in a time capsule that nobody believes me exists.
Well, we believe you.
Not my physical hand, like a tracing of my hand.
I should hope so.
Well, so I have so many questions, but the one question I want to ask before we start is, what's your favorite sandwich?
Pizza.
That's where we have to jump in. What did we say?
What did you say, Daniel?
Pizza, obviously. I'm in Colorado. Pizza and beer is my favorite sandwich.
I'm gonna go cry now. I'll be back in a couple minutes.
Just questioning anything. Yeah.
That's like a really American question, to be honest. Like, I don't know. In Germany, no one asks what's your favorite sandwich. So I would guess something with avocado or something. But we are more bread people, so we usually do bread, and then that's it, right? So
Yeah, I would like that, bread with my bread. I can picture. I'm gonna ask that in my local bakery. It's just like, what bread would you suggest to put on my bread?
so many different kinds. That's the thing.
Yeah.
If you've never had avocado toast, it is a formative experience. You could turn your nose up at avocado toast. A lot of people do until you eat it, and then you're like, wow, this is heaven.
I'll have two. But so the sandwich question. All right, now I think we have to jump into some quantum, even though, it's fun to talk about sandwiches. But from a quantum perspective, I'll pose this to our esteemed guests. I wanted to say 3 E's there, but I forgot one. So when we say, how do you test quantum safe implementations? How do you do that?
Is that to me, Daniel? You're like, what the hell is that question?
And if we're in the same place on the screen, then I'm literally pointing toward you right now.
No, you're not. You're not. I'm not on that side. But
are you on this side?
Yes.
Okay.
Of course, we're looking into benchmarks, for example. So into performance, how fast can you break something, and how fast can you therefore solve a problem? And also on the benchmark of how fast can it be done. So I would say that can at some point out to why something super safe, and then could be named as post-quantum safe. Yeah.
Desiree's spot on there. A challenge we have today is that we could do benchmarks based on math, and mathematicians are amazing, but we can't really take a quantum computer and put a legitimate RSA key in front of it and say factor this key, and it actually factor the key. Even today, when we see RSA being broken, we're seeing them do that through using 5-bit keys. So it's not practical. It's not what anybody does.
Also, post-quantum still means it's run on normal computers. So it's not like quantum crypto or something, which is running then on quantum computers. So, yeah.
So what we're hearing is a lot of math involved in this, especially when it comes to the benchmarking. But if we don't have the quantum computers as of yet, how do we know that we're heading in the right direction with that math, right? Because usually you're trying to solve for X. If we go with any, simple math equation, it's like, okay, what's that X? And kind of why should we care about that X when it comes to quantum?
We've got algorithms to break our algorithms, our keys. And so we know that theoretically they work. And we know based upon that, how strong a key length is based upon the algorithm, the crypto algorithm we're using. And so what we're really doing here with post-quantum is we're creating new algorithms. And so far it's just algorithms. We're creating new algorithms that are going to be harder or hopefully impossible for what we expect the first true generation of quantum computers to look like.
And in terms of time frame, what is your estimates when it comes to quantum? I know there's a bunch of different studies and research being performed, but what are you thinking?
I've got a very specific answer to this because I know exactly when we're going to have the first true generation of quantum computers. They're going to come out 3 days after Half-Life 2 Episode 3.
That seems appropriate because today's theme, if you haven't gotten it, it's a little bit of a Half-Life reference for you who haven't played it. If you haven't, just pause this episode, go play it, and come back.
Don't get into this. You will be heartbroken.
Yeah, you'll be heartbroken because it's so good, and you want a part 3 to it to come, and yeah, it'll be right there around quantum.
So maybe once we have the last Game of Thrones book or something like that. So maybe
that's
add it to the list.
You don't want to get me started there. I read 60 books a year, right? So I got 3 books into the series, and I was like, this is too predictable, and he's never going to finish it. And so I stopped.
What's worse, George R.R. Martin or Patrick Rothfuss?
Patrick Rothfuss, hands down.
That's really awful.
Because his first book in that series was absolutely amazing. The second was a little weird, a little cringe, but I had to read the third, and it's been a decade now.
Yeah, light reading.
I sometimes reread it just to still be on fire for the third one.
You're keeping it going. I love that.
Yes.
The optimism is strong.
I think when we're talking of quantum computers, though, the thing we need to understand is that they are like we talk a lot about quantum computers and how amazing they have the capability to be, but today they require such extreme physical isolation just to work or be like 17 factor less reliable than the computer on your desk. And so where we see improvements is with chips that reduce the total error rate. And even with a recent chip that we announced that reduces error rates by like 90%, that would make quantum computers go from being 17 factor less reliable than your desktop to being 16 factor less reliable than your desktop. And even if we create this perfect isolation chamber that makes them more reliable, and we continue the process of improving our chips that do error correction, we're probably never going to see a point where we're just sitting there with a quantum computer desktop.
Yes, but I guess that it comes back to the question, why should we do it then, right? So maybe Tristan was about to ask that.
Yeah, exactly. So that's kind of where we're going with this, right? Is why should we care about this? Why should we look into this? What is our current state then?
Do you want me to do this one? Or?
You remembered. Awesome. So yes, again, it's not just about what could happen with a quantum computer, which could in the future exist and be relevant to break some of our asymmetric keys or something. Then we still could look into how can we improve our security today. So we do, as AWS, we still see this risk as possible. So this is why we do invest and do also others invest. So there's like NIST and other great players are also investing. Europe has a lot of regulators investing in it. So from a regulation point, I know people hate it when I say this, but you have to comply at some point, right? So, but why do you have to? It's because it's more secure. So it comes back to what I said at the beginning. You can test how safe is that algorithm, and is it safer than the one you're using already?
I think there's a follow-up to that, and that is we tend to over-index on things that might not be as important. And when we talk about post-quantum crypto, we're really doing that. We're over-indexing on the quantum computer, right? We have a natural progression of cryptography through the last 50 years or longer, depending on if you want to go back to crypto from like World War II. And we're kind of talking about this as an issue with quantum computing, but this is really just a natural maturation of how we do cryptography. We started with, PGP, but whatever. We started with like RSA, and RSA is straight math. And then we moved to elliptic curve, which is kind of a mathematical horseshoe that you select 2 points on. And the keys are like 3 times as strong as RSA for the same length. And so we already were in that going in that direction of maturation. And now we're like, what's the next generation look like? And the next generation looks like lattices.
And we take this pause to say, hello, Rajesh. Thank you for joining. But Pete also puts a question that I think goes along with this. Should we be more concerned with quantum security of AI security? So if I were to say is, which one should we be more scared of? I think Pete was getting at.
Well, there's three types. I'm sorry. Go ahead.
Quantum security or AI security, I think was the question.
So, I'll
go
ahead and jump in. Okay, so when we talk about quantum security, if we talk about quantum computers, then they're not a practical risk today. If we talk about the maturation of computing power versus the strength of our keys, our crypto keys, then we should be concerned about moving to post-quantum crypto simply for the stronger keys. But we don't actually have quantum today. So if we just rephrase that to, are we more worried about compute expanding past the ability of keys to protect us versus AI security? Well, then we have to talk about what do you mean by AI, because there's 3 different types, right? We've got predictive AI, which is when you like feed all your biometrics into a machine and it's like, congrats, you're going to live a healthy life, which WebMD tells me every time I have a sore foot. Or you've got generative AI, which is basically our new Google search. Like generative AI, you go to your preferred tool, or you go into one of our like bedrock tools, and you pose a question, and 80% of the time it gives you a great answer that you can copy paste to like one of your own customers or your internal team. It's great. And then we have the third type, which is like general intelligence AI, right? And that's like the Skynet type thing. Well, that's our fear for Skynet. So I do think we have different parts of this conversation, because AI is all about information, like gathering data and performing analysis on it. And it can make us all far more effective in what we do very quickly. Whereas quantum security is all about maturing something that exists today into the next iteration, more secure iteration of it.
I think it's quite interesting, yeah, because I saw that I had a head start. He already explained, like Pete, thanks for the explanation. So it's more about data protection, I see. So there's a lot of, and on my daily work, I see a lot of data protection questions. And this is from the point of different, because with post-quantum crypto, we're looking into like data in transit. And for what you're telling here is you're like deliberately giving data away into an LLM, right? We're always talking about responsible AI, and you are also part of that responsibility on what you're sharing on an LLM. So of course, there are now new regulations and which look into how we can protect consumers. I think that's also in the US, right? There's also a lot of regulation. I feel like we're so regulated here in Europe, so I'm sometimes not sure what is allowed on the other side.
We do state level regulation for like privacy. We don't really do federal level regulation for privacy. So we've got a hodgepodge. We could spend a couple hours talking about that if you want to, because it's also interesting. But
But before that, I was actually going to say, if we didn't talk about the data you're putting in there, a lot of it can be actually tested with mathematics. So with post-quantum, we're looking into math, and with AI security, we're also looking into how to make sure that what the outcome, like with hallucinations and things like that, can be actually proven to be right. So that's things that can be done.
Can I slightly re-ask this question, but instead of AI, saying like quantum security versus, or just quantum, I guess, development versus like supercomputer development? Like, is supercomputers going to develop in a way that would maybe instead be more realistic than quantum? Like, can you discuss?
I think our traditional computing is almost 100% accurate. Like when your processor means to calculate a 1, it calculates a 1 like every time. And thus, if we're talking about how we're going to break current cryptographic algorithms sooner, we can talk about quantum because it's really cool. It's a really cool topic. But the reality is you're probably going to break that sooner with just a continued maturation of our classic traditional computing technology.
Yeah.
And the scary thing is maybe somebody already has.
And I think the interesting thing too is when we're going into the risk section, one of the things we were talking about is this store now, decrypt later aspect of things, right? Where you have individuals looking like, okay, I might not be able to break this encrypted data now or decrypt it. I'll just store it away, and just when computers become that point where they're powerful enough, then I should be okay. Whether it take 10, 15 years, may not be as relevant for, your average, let's say, credit card, because hopefully they expired by then. But if you're at that breaking point, depending on the time frame, there might be some overlap there, right? So
all data has a lifespan.
Yeah.
For example, if I go and make a credit card transaction and I get a hamburger and they encrypt that, right? Or I get a pizza and beer sandwich and they encrypt that, and someone captures that and is able to decrypt it the next day. And so they have my order. So they've got my data. They haven't actually gained anything. There's no risk to me other than thinking I'm a bit weird.
Yep. Your pizza sandwich.
But would that be more of a concern if it was biometrics? I mean, biometrics.
It's well, your biometrics are not as static as you might think they are. And here's what we see with biometrics. We think of biometrics and you're like my fingerprint, but it could really be anything medical related or physical related, right? Mm-hmm. And we already know that computers have a immensely tough problem with biometrics for certain demographics, and so they're not very accurate at that. So like if we're talking my fingerprint, well, that's not necessarily a huge risk, but it is relevant. So I think that's where we start talking a little bit more about risk. And the store now, decrypt later always is predicted on a threat actor having access to your data. And so then now we need to just talk about data privacy and data sovereignty. So now I think this is great because data privacy I'll take, and then Desiree, you could talk data sovereignty because that doesn't exist in the US. And so that was a joke. It does. It's just different. We don't have GDPR. So when we want to talk about that, the threat actor doesn't intrinsically have access to your data. If you have a mature, well-architected infrastructure where your data at rest is protected and your data in transit is controlled, like for example, here's the threat, right? You've got a compute instance and some storage in like an AWS region, and you send that to another AWS region, and you're like, what about the man in the middle? Well, if you man in the middle a fiber optic line, we know because it impacts the data signal, and we see like, hey, our signal's wrong here, and it doesn't necessarily allow you to pull a single thread of data out. And so that's really a minimal risk. The real risk is you go into Starbucks with your Mac, you sit down, and you're like, it's like Starbucks network, and then it's like actual Starbucks network, and you're like, oh, I guess I'm going to connect to the actual network. And it's actually a threat actor who's copying your data. Now, that is a risk if you're actually transmitting data from your laptop to a third party. But again, that's really only a risk if you're not using a VPN.
Yes, and I also find just a couple of comments in the chat. If you got the final destination before joining us, that's an interesting kind of coincidence. And encrypted burger. Encrypted burger is a little salty, but according to
I call dibs on my.
Wouldn't that be a hash burger? That'd be a hashed burger. The salty one is the hash burger.
See? Went to the seminar, I see. According to the movies, all biometrics can be broken. And what happens when programmers, writers, when AI has better Grammarly? Interesting. And how do you defend against that? I've heard of forward perfect secrecy, which I think makes that more expensive. I'd like to hear a little bit more about that. If you want to drop that in, Lambda driver. Interesting enough, Lambda driver. We had a question earlier about who would pick Lambda, and I have a feeling you would have picked Lambda in our questions. Just a wild guess. what I think we talked about a couple things, and just to summarize a little bit, is there's a couple of current risks that are out there, mainly around the compliance aspect, the store now, decrypt later, even though, to Daniel's point, a lot of the data has an expiration date. So if it comes out around the same life or lifetime as a certain, life half video game, if I don't specifically say the name, these are the kind of things we have to consider.
We said it like 3 times already.
Yeah, but they didn't know. We're just switching around. Supply chain vulnerabilities in the future might be a future risk, right? Because you're thinking,
Big risk.
Yeah. Hey, is everything going to be upgraded? There's still things that today aren't upgraded, and we're working on modernization and all those good things to get security up there, to make compliance standards and things of that nature. But in the future, that's going to be a big risk. So I think there's a couple of things we need to consider. One is that everybody is liking and subscribing and sharing out the stream. Thank you for that. But the other thing is, from a customer standpoint, from an individual standpoint, a practitioner standpoint, I think they need a couple of pointers. And how do we get some pointers? Well, we jump into a legend, a SideQuest legend, where we start to dig in from a customer's viewpoint of, hey, what is this topic and how does it apply to me? Well, we have just a story for you. And I try to do my announcer voice, but I'm a little under the weather. So as story has it, one security engineer, the right man in the wrong place, was trying to establish quantum security controls, but now faces the challenge of scaling and optimizing and implementation across the AWS environment. Because, hey, some of this stuff is theoretical. Or is it? One day I'll get the voice down. But one of the questions to pose is, if you have the security engineer in a financial services background, right? Your first mission is to, hey, how do I secure things quantumly, right? That's kind of a question that pops into people's head. But what would your team's most valuable skill be in this I was going to say PQC world?
So, when we talk about somebody from the financial services industry, that's somebody who spends a lot of time with encryption, because encryption tends to be a bigger topic in the financial services industry than it is in other industries. Like when I'm dealing with U.S. government or Canadian government entities, they're like, how do I get FIPS validated crypto? But then when I'm talking to like financial services industries, they're like, no, I need my own HSM and I'm going to be using it for all of my keys. And that is a hugely different architecture design, right? And so you want to talk about training. So I think the very first thing we have to talk about here is inventory. Like the very first thing, like the training thing you have to do is you can't secure something if you've not quantified it. And so you have to first say, where is each cryptographic operation occurring within your workload? And what are the cryptographic libraries, the actual encryptor, and what are the cryptographic algorithms being used for those? And then you have to say, based on all of these, which of these are our biggest risks? And as much as I'm talking architecture and you're talking training, I think these are one and the same here.
Yeah, and just really quick, I would say, as we look at the board as we have it up now, for your first time joiners, if you're not familiar with the SideQuest board, this is just an illustration of that person who's trying to figure out quantum security and how it applies to them in the financial services realm. So we walk around and tell a story. And you said something about understanding your keys, understanding maybe having something like KMS in the environment to start off with, right? We manage our keys, whether it be managed or customer managed. Well, if we continue on along that story, is okay. Desiree, what skill do you think is most valuable to those who are figuring out quantum?
To be honest, I thought about this, and I think it's not so much about of course, you can say which services you're using and do like an inventory, which is the perfect right answer Daniel gave. So I was like, well, he already gave it. What should I think of now? So, so we as AWS are already doing a great job at giving you at-hand services. So of course you do have KMS, you do have Secrets Manager, ACM, like Certificate Manager. Things like that, which are very important to make sure that they're passed over securely, which is the important point with post-quantum, right? The key exchange.
Yeah, and I think you named a bunch of different services that also apply to this scenario, especially from a security engineer that says, hey, I can turn on anything within reason, within my budget, within my power, because I am not the top security engineer yet. But as we continue along the board and say, hey, I got KMS, I got Secrets Manager, and I think
don't forget Certificates Manager. Don't forget Certificate Manager.
Yeah, and Certificate Manager. If I can find it. Wait, did I enable it? I don't know how to use Certificates Manager. That is the problem, because I am just a lone security engineer that's going through this path and trying to chart his way. But I think that's an interesting point is, will services like Certificate Manager matter in a post-quantum realm? A quantum realm. That's funny. But will it matter in the future?
Yes. Why, I mean, why wouldn't they? So signatures are, of course, they're a bit more. Sorry, that was a lag on my side. So signatures are substantially more secure at the moment as RSA or elliptic curve, but they are still also at risk. So they can also be in scope of looking at. So you still need them for certificate, root of trust, right?
Yes. And
our whole internet is built, and like secure computing is largely, well, that is the trust aspect of secure computing is completely built on PKI.
And thank you for answering those questions the way you did, because when you're on a side quest, you try to answer and ask these questions of, why do I need this within my environment? You mentioned KMS. Okay, key rotation requirements, things of that nature. Certificate Manager, as you mentioned, it's the backbone of a lot of different things all across the internet. And you look at all these services, especially when you're optimizing costs, and when you have these conversations with management or other individuals, like, well, we do need some of these services because A, B, and C, and we just got some really great, I would say, answers from our sages today. I think the solution that we're trying to move towards, and I'll do this because the road is never straight. It's always crooked a little bit, right? Because you're building it a lot of the time as you're walking across it. You can plan it out, but in the words of Leonard Snart, if you never heard of it, is you create the plan, you execute the plan. Plan goes off the rails, you throw away the plan, create another one. And that's what we like to do, because when you're looking in and trying to understand, hey, maybe I need something like, I don't know, Security Hub, right? To gather all the information. You said about inventory. How do I know if I'm in compliance within my environment before quantum even hits? So all these different things we need to take in consideration. We can have config, we can have ACM, but the main story of today is the same as last week. The road is not going to be straight. It's going to be a little bit curved, and you're going to do a little bit of a loop-de-loop. But what you're trying to do is iron it out the best way you can with the skills that you have and the knowledge that theoretically exists out there, right? And that's my joke for quantum for today. But I would also ask is, when you're thinking of what is the most costs that somebody can have when they're thinking of quantum safe implementations. So when you think of, hey, what is the best way to optimize for this in the future? Because, hey, it's not here yet. And I want to implement some protocols to maybe help in the future. But how do I optimize this approach? Because money and budget is a factor.
Money and budget is a factor. So is that a question, Tristan?
Yeah, it's so to rephrase is, how do I make, let's say, senior leadership understand that we have to start investing in today in order to protect tomorrow?
This is what I call something that is consumable, right? Like if you go to your senior leadership and you give them a rock and you're like, hey, I'm gonna need you to eat this rock, they're gonna be like, no, I can't do that. It doesn't work. It's not consumable. So the way we make something easy or consumable for senior leadership is we make it easy for them. And we go to our CIO and we say, hey, it's not going to cost us a lot of your tech labor to implement this. We go to our CFO and we talk to them about the cost of it, right? And before all of that, we get the buy-in of our CEO on how important it is to continue to mature our encryption algorithms, because frankly, it's a great sales pitch for your customers. If you work in a regulated industry and you can go to your end customers and say, hey, we're straight up post-quantum, yo, they're going to appreciate that. It's a good message. It sells. So this really isn't a terribly challenging thing for them to do. There's two parts of it, because we live in a layered accreditation universe now where they have to inherit part of this from AWS or from another infrastructure if they're using another CSP. And so document the migration plans for post-quantum cryptography for that CSP, and then just track it. If they say we're going to have this done in a year, check in again. The other part is to take your inventory of your algorithms and then document how you're going to update those to post-quantum cryptography algorithms. And these are typically pretty simple to do once those algorithms are fully available.
I think what is also like pretty neat, not to say that we're emphasizing on it, but we do invest ourselves a lot in post-quantum. So you can just hop on the train and say, well, AWS is already investing a lot. They're making their services post-quantum ready, and you can consume them. So from one side, you can just enable, for example, the endpoints for hybrid post-quantum crypto, and you're already like doing a small check mark, because it's completely fine to go with that hybrid approach and say, well, if we're there, we're there. We can do our inventory, we can change that over time, but maybe there are already like some small easy wins, right?
Yes. And that's what we like to have, small, easy wins, because we break things down to the ones and zeros. Can't say that joke with quantum, though. But I would say the best way that we could go forward is to hit the pause game button, as I like to call it, or the Zach Morris timeout, as we also hear it. And that's when we jump out of the side quest and start to ask the next set of questions. And that question that we like to ask comes to, how do you conserve City 17's AWS resources? Another life half joke. Reverse that and you'll know what I'm talking about. So 10 points to you if you get this reference and this city. So 1, 2, 3, or 4 in the chat. Feel free to put it in. What are we leaning towards? Are we going to optimize the computer resistance? That means resource scheduling. Combine cloud auto scaling, Lambda, lab costs. And I'm looking at you, Lambda driver. So a lot of things. Especially, I'll bring up this. Understand you use short-long keys that change frequently, so a bad actor might have to break, let's say, 5 keys instead of a single one. Is this still valid in a post-quantum world?
It is valid, but you still have the individual data sets, right? So we're the way we often do data today, or encryption today, is you have like a primary key, and your data key is derived from that primary key, and then that data key changes frequently, and that's how we do individual session security, or like perfect forward secrecy security. And so if you were to capture the primary key, then you have all of the ability to decrypt all the data. But if you just capture that one session key, then you can only decrypt that one session's worth of data. And so it limits the scope, the blast radius of a potential breach.
And I would say thank you, Lambda driver, for driving that question. I was saving that joke for the right time, and I think it played out. Many small solutions solve large problems. Yes, I like that. And in a scenario, are we the baddies? Well, I would say, since we're talking about quantum, we're neither 1 nor 0, right? We're a lot of different things all at once. So I'm just going to keep with the quantum jokes until somebody stops me. Most likely the end stream button. But where do you fall, Desiree, in 1, 2, 3, or 4? Which one do you think is the best way to conserve resources when it comes to post-quantum thought process?
Honestly, what is that? Conserve CD17. I'm like still a bit at loss there.
Yeah,
Conserve, just put organization names, AWS.
Oh, okay. It's like
Yeah.
okay. I would say with one, like optimizing, but I'm not super happy with those choices. Maybe Daniel can go first. Let's see what he says.
Answer, non-answer, because we don't optimize at the single layer. We optimize at the workload. So we look at the workload in its entirety. We look at it holistically. We look at the customer's business requirements vis-a-vis their workload, and then we optimize across. So my answer is the quantum all states at once.
And that's where we pop back out of the question, because that was a drop mic. I couldn't answer after that. So, right? See, we're having fun here. And this is the way we like to go about understanding and kind of going through, especially after a side quest. So I think we touched upon a bunch of different topics. But the one that we want to get into is, how do we implement? How do we have some steps that are tangible that somebody can take today, for tomorrow, or in the future? And I would go down here because Desiree's down here.
Yeah, that was the right one. So yes, as I already spoiled a little bit, we do have our migration plan. So we as AWS, we are already taking, we like to say, the heavy lifting of implementing all of that. So from our side, what we are doing is that we offer endpoints which can then serve hybrid post-quantum algorithms. So you could choose, if you offer us already a post-quantum algorithm, then we are awesome. We are like, yeah, we take that one because that will be our priority. Or if you say, yeah, I still have like a normal algorithm, I use RSA or elliptic curve, then that's also fine. So you don't really break anything by just going over that endpoint, which we already offer for KMS, for secrets manager, for certificate manager, and also for the transfer family. So I would say that from that point of view, it's already something easy win, right? And then also on our side, I'm not sure if everyone knew, but we do on our back end already provide TLS for a server, like our service communication. So all of that will go over the TLS 1.3 hybrid post-quantum crypto. So we do take those steps from, I would say, the server side. And from the client side, you can choose to implement those steps as, I don't know, Tristan already said, but we do invest a lot in our AWS libcrypto, which is like something you can use in your SDKs, and then you can consume our services using those SDK commands, I would simply say, like functions, and they can then serve the right algorithm, I would say. Yeah.
That sounds like some good next steps to start to think about. Is, again, we're going to harp on those, those short-term small wins that eventually build up. And what we like to say around here is, when it comes to security, what is your organization's target state security strategy, right? What is the roadmap that you have for yourself? And you want to build into your roadmap of understanding of quantum and what AWS does for you and what you have to do in the cloud. And if you get that reference, 10 points to you, I would say. 10 points. I was going to say 20, but 10 today. It's the shared responsibility model. That's one of the big items. And a lot of the stuff Desiree was going over is like, hey, AWS is doing all these cool things in the back end for you. So now when it comes to preparing your organization for the next steps, you have a basis to stand off of, and you also can read about it too. But I think one of the things that we can also jump into is the agility aspect. And maybe Daniel, you can kind of hop into this, right? You saw what I do there, but so hopping into the agility when it comes to crypto, what is the plan for that?
What is the plan for that? So really, it's going to be pretty easy as just updating the algorithms you're using from like RSA to whatever the post-quantum crypto is applicable to that type of encryption that you're doing. And for all of our services, we will eventually make that very easy for you. We've already done that for some of our services, and we will continue to do that as we continue to roll out post-quantum crypto. And I think where the like tenant needs to really focus is, well, one, on that inventory. It always goes back to that inventory, because a lot of encryption, some would argue most encryption, it depends on your workload, actually happens at your application. And so for a lot of customers, if we're talking agility, then you need to take that inventory, which is going to include your application. And whatever data goes from in use to in transit or at rest, it's going to be encrypted. And it's probably going to be encrypted at the application layer first, even if it's encrypted again at another stage of the network or storage. And so you need to be aware of where that is, because you're going to need to be implementing those post-quantum crypto algorithms at your application level. And that should itself also be just like updating OpenSSL, right?
Yes, and I have to point out Pete's comment of the motor on my castle will not help me. Thought that would work.
It will. Your mode is actually stronger than we often give them credit for. If you consider like an AWS infrastructure, you've got at your VPC itself, you've got your security groups, which is a virtual firewall. You've got NACLs, which is like your virtual router. If you also implement cryptography, or not cryptography, egress controls at your instance, then you've got like your Windows firewall, right? Or your IP tables for Linux. And so you've got another layer right there. And that's not even the edge of Amazon. You're not even at the edge yet. You still have other layers of protection between you and a threat.
Yeah. And then you still have your castle walls. And for you new to the AWS defense in depth, exactly approach, we usually use the castle analogy a lot. And think of the walls, think of identity. We didn't even touch upon identity, right? Just thinking about how that will apply. Least privilege, and I have to say it every show. Least privilege, least privilege, least privilege. I say it 3 times for the people on the other side of the internet because it's very important.
Can I ask a bit of an outfield type of question? Because as far as quantum security goes, maybe we're not in the realm of theoretical because it is things that we're implementing today. But as far as like, when we were discussing our risk and each organization's appetite for risk. So for like example, when we're talking about maybe defense industrial base type of customers or something along those lines, where they might actually be, a target or be more concerned about risk from like nation state actors with the potential to not really know what capabilities they have, especially nation states are usually well funded. So do you think that there's any sort of risk that say people that would be concerned about nation state threat actors? Is that something that they should be putting into their threat models? Is something that they should be implementing? Is that more of a realistic concern right now?
It comes back to what you said, the risk appetite, right? How potentially likely is that someone who's already in a risky business, so to say, fears that someone could take their data and at some point look into it and make some sense out of it. So I would say, because those people are more sensitive to risk, that it makes sense to already invest. And like we talked about supercomputers, and those are very real. So we can already make things more secure by implementing those steps now. And I guess that's also why we see a lot of regulators pushing for it. It's not just because it could happen in 30 years or something like that.
So we've got, I'm sorry, go ahead.
No, I was just going to say, I think the interesting point that comes with this is you have to build knowledge on those topics. And if you see where I'm going with this is we like to do something called Knowledge Quest, Daniel, Desiree. And what that means is, hey, what is the homework, the takeaways, the things that people have to do on their own time of just like, hey, I learned a lot about stuff today, but I can't exactly put all the words in the right order, not by myself. So the way to go about that is, hey, go on the Knowledge Quest. And that Knowledge Quest today, we're just going to keep building aura, especially since we have sages that are proficient in the quantum variety, right? You see the radiance coming from them when it comes to quantum knowledge. But for me, just a regular person, I think the first step is to understanding some of the different services, right? Well, I think that's an important aspect. So let's do this. Let's look into KMS and kind of zooming in a little bit using hybrid post-quantum TLS with AWS KMS. I think this is a good place to start off. If you're at that L100, that level 100 status, this is where you want to be, is looking in the guides to build up that knowledge. And from there, you can start to look at, hey, what is the compliance and security during post-quantum? It tries to summarize the migration path, right? What is secure connectivity? What is the things that we need to care about, especially when there's diagrams? 10 points to those who love diagrams as much as I do, because it helps you to go through and understand what exactly we're speaking about today. And this is what we want to do, is delve in one piece at a time, because you'll eventually get to being level 200. And that level 200 is, what is the actual plan? Right? You're that person. I built my knowledge, and then you go think of our security engineer in our SideQuest who's like, all right, I know all the knowledge, I know all the things. Now, what exactly is the migration plan? We have to figure it out. We have to learn these different aspects and these items. Right? So go to the blog post, figure out what services are supported from a quantum, I always want to say realm, variety. I'll use variety for today. And then eventually you get to a point where you're like, hey, let me actually dig into some hands-on items that I can possibly work with today. Like, hey, how do I import a key to KMS with a post-quantum TLS connection? That seems like a fun weekend activity, right? You just do a little bit of quantum. And yes, and we will broadcast these different links to our social medias. So you can delve on these adventures and tell us, hey, these worked out. These like to build a little bit of experience, XP points, so that you eventually can level up. And I go through that point slowly because there's a lot of reading, and you should take it slow when you're reading through this, unless you're a speed reader and you jump back out of it, because it's always fun to learn about quantum and think about the importance, right? And some last, I would say, closing thoughts, as we have 3 minutes left on the clock. So I'll start with you, Daniel, and then we'll go to Desiree. We reverse, right? The order.
Cool.
What is the closing thoughts when it comes to post-quantum security and implementing it?
The most important thing is going to be to build that inventory of cryptographic operations. And if you don't have one of those for your information system, take that as homework to build it, because all of this other documentation is what you're going to apply that to.
Yes. And Desiree.
Easy win. You can use the endpoints, which we set. So for example, for KMS, if you're already using it, use the PQ endpoint, which is pretty easy win. And then you could also build the knowledge around it. So you have your inventory, like Daniel said, but you still need to find the knowledge for upgrading, for example, for TLS 1.3. Yeah.
And I would say I'll save Russ for last, because Russ always has a very important one. Mine is continue to build your XP points. And I said it before, it's your experience points, because eventually you want to level up your knowledge of security so you can level up your environment and your trajectory and your fun, because after you learn something, it's pretty fun. And then you can talk about sandwiches all day and what consists of a sandwich. So those are the steps that I say for success. But Russ, what is another metric of success?
Please create your incident response plans.
Yes. That is the 10 billion point word of the day plan of the incident response variety.
We could do a whole session on incident response planning if you want.
See, that sounds like
I would love it.
Yes.
I love it.
Sounds like a sequel.
No, don't do that. Don't do that.
What is that?
Don't do that.
So yeah, it's fun until it happens and we have everybody here talking about incident response plans. Yeah. Well, maybe next time. Maybe in another life. Or
let's not.
Yeah. But until the next time, thank you, Daniel, Desiree. You've been our Great Sages hosts, and the experience point that you have shared has leveled up us a little bit, just a tad bit. And thank you, everybody joining today from wherever you may be. So, the main takeaway: continue to figure out what sandwiches are and which ones you're going to eat. Until next time, have a great one. And take care.
Later all.
Take care.